for only $470 in 1973, or about $3,330 today, you could have purchased this Pioneer SX-828 stereo receiver. This guy was rated at 54 watts per channel into 8 ohm loads from 20 Hz to 20 kilohertz at not more than 0.5% THD, and boasted a frequency response from 5 Hz to 80 kilohertz of not more than plus or minus 1 dB. It weighed in at about 38 pounds, and this particular unit has the much sought after gold finish. Now, I don't know if the prices I quoted were for the silver faced one or the gold faced one, but it turns out that today the gold faced ones are much more sought after. I will do the standard tour of the front, the back, pop the covers off, and we'll see what's going on in the front and the back. Now, this was lent to me by one of my good buddies, and he hadn't tested it in a while, and it had some issues. Luckily, it has a separable preamp and power amp section, so I was able to narrow down the preamp section and fix that, which really amounted to resoldering the tone control board, I would call it, and you'll see that in the tour. I mentioned that. That was the main issue that it had. And then, of course, after the tour, I'll go over all the data, and finally I'll tell you what it was like to listen to and use the SX-828. Here's a close-up view of the Pioneer SX-828. Starting on the left, we have a power on-off switch as well as a speaker selector switch, and you obviously can select between 3 sets of speakers, or you could go with 4 speakers. And you can go with either A plus B or A plus C if you wanted to run 4 speakers. It does have a speaker off position, which is nice. I am not a big fan of having the power on-off switch on the same control as the speaker selector switch. We have the ability to run 2 sets of headphones. That's kind of nice. Bass and treble controls are here, and the balance for each of those is on the 2 rings. We have a low filter and high filter, and then we have our normal balance control here. Our volume control is here. We have a loudness switch, a 20 dB muting, and then we have the ability to switch between 2 tape monitors, and we have the stereo reverse left plus right mode selector here, and then you can see we have an auxiliary input, and we have 2 microphone inputs, these guys here. We also have our just normal phono selector, and you can have 2 phonos hooked up if you want, and then you have your FM auto, mono, and AM selector here. You can change the brightness of the display. That's kind of nice. So it has 2 positions. Then we have an FM muting switch here. Obviously our tuning knob, and we also have a tuning meter as well as a signal strength. And it looks, pretty good. I think it has a very nice look with the kind of blue background, and it also tells you what speakers you've selected. This obviously is the rear view, and we'll start with our 2 phono inputs, and one of them's for a magnetic cartridge, and the other is for a moving magnet or moving coil cartridge. Kind of interesting there. Ground lug for the phonos. This is our auxiliary jack, of course, and then we have the ability on tape 1 to use DIN jacks, or you could use the normal RCA jacks here, and tape 2 is here, and it also could be set up for 4-channel if you had the right adapters. We have pre-out main-in jumpers here, a user replaceable fuse here, our antenna connections here, as well as the AM rod antenna. Then we have 2 unswitched AC outlets, 1 switched AC outlet. And here are our speakers. Now, they have these funky terminals that Pioneer used for a couple years, and these are actually what plugs in there. They're not the easiest things to get, but we do have the ability on this particular unit to run. Right now it's A and C, but you could also move that over if you wanted A and B. But these are what the actual adapters look like when they're plugged in. Here is what the inside of the SX-828 looks like with the top cover removed. You can see we have our tuning adjustments labeled right here. It's very nice that they did that. Power supply caps here. Underneath this little cage are the output transistors, and you'll see that closely. Obviously, power supply transformer here, and our actual tuner is there. Here is a view of the output transistors once that little screen cage is removed. The bias adjustments are here, and the DC offset adjustments are here. And when this cover is removed, you can gain access to the other DC offset adjustment, which is over here. Here is what the bottom view of the SX-828 looks like. Kind of gives you an idea of what's going on, how it would be to work on. And I know that this has been worked on. I don't know to what extent. I can tell you that you'll see in a moment where these wires had been unsoldered. I think possibly this capacitor, and I believe it's this one here, have been replaced because they're not the same style as these. These guys look to be original here, the power supply capacitors. Here's just another view of the bottom, kind of just seeing where the switches and the controls are on this board, and this board is what I ended up reflowing all the solder joints on in order to get the right channel to work properly. And this is what I was talking a moment ago. Somebody has obviously been in here and soldering and unsoldering, and so just you could kind of just tell that this thing has been worked on. Right now we're looking at the amplifier section only of the SX-828. In this case, we've got it putting out about 5 watts into 8 ohms. You can see the THD is better than, we'll say, 0.01%. SNRs are better than 80 dB. The amplifier itself has a gain of a bit over 33 dB. And for the most part, it doesn't look too bad. Our THD plus noise is better than, we'll say, minus 77 dB. Right now, we have the SX-828 putting out about, we'll call it 54 watts into 8 ohms. Gains right around 33 dB, a little bit more than that. SNRs are at least 87 dB. You can see our THD, the worst case would be, we'll call it 0.08%. Now, you can see a big difference between the THD plus noise, and a lot of that is because of the 60 hertz hum bar coming through more on the right channel, and it does have some spurs that are higher, so that kind of explains that. Now, the specification says that the power output with both channels driven should be 54 watts into 8 ohms with a harmonic distortion of less than 0.5%, and we are definitely meeting that requirement. It also says at 1 kilohertz with just one channel driven, you should be able to get 70 watts out, or at 1 kilohertz with both channels driven, you should be able to get 60 watts into 4 ohm load. So I'm going to go ahead and see what happens as we increase the input signal and the output power. So let's go up a half a dB. We're at a bit over 60 watts, or close to 60 watts on the right channel. And you can see we're over 1% THD. So it's not going to quite make it to the specification level with both channels driven. I'm going to go ahead and turn off the right channel, and let's see what happens when I drive just the left channel. It's supposed to be able to do 70 watts into 8 ohms at 1 kilohertz with just one channel driven. So let's see if we can get there. Yeah, we're not going to get there with the left channel. It's 1% and we're at 68 watts, so we're not going to get there. Here is the frequency response from 20 hertz to 20 kilohertz with the SX-828 putting out about 5 watts into 8 ohm loads. And this is just the power amplifier section. The specification is that it should be plus or minus 1 dB from 5 hertz to 80 kilohertz. Well, we're not quite doing that whole range, but over this range it is down maybe we'll call it 0.2 dB at 20 hertz and only down maybe 0.3 dB at 20 kilohertz. So the frequency response of the amplifier section looks really pretty good. Right now we're looking at our standard THD SNR plot from 20 hertz to 20 kilohertz of just the preamplifier section, and we've got a 2 volt RMS input signal into our auxiliary input. The specification for the preamp section is that the THD should be better than 0.1%, and we are definitely meeting that requirement. SNR is right up around 97 dB. And you can see that I've adjusted the volume control so that we have 0 dB of gain. Right now we're looking at the preamplifier section of the SX-828. I'm using the auxiliary input with a 0 dBV signal applied, and we are sweeping from 20 Hz to 20 kHz. The specification for the preamplifier section is that it should be plus or minus 1 dB from 10 Hz to 40 kHz. Now, within the 20 Hz to 20 kHz range, we are plus or minus 0.7 of a dB or so. So I would say that it's doing a pretty good job of meeting that specification. Right now, I've got a 500 millivolt 1 kilohertz signal going into the auxiliary input, and we're measuring at the preamplifier output. And there is a specification that with a 500 millivolt, we should be able to get 4 volt outs. I don't see that being the case at all. But it does show that our THD is better than 0.04%. We're showing about 8 dB of gain, and our SNRs are above 98 dB. So it looks pretty good. I'm going to go ahead and increase the signal level a bit till we get our maximum output voltage, and we'll just see where that falls. So right now I've increased the signal level to about was it 1.9 volts RMS going into the auxiliary input. Our volume control is set to give us the maximum amount of gain, which is about, we'll call it 8 dB. And you can see just kind of from the waveforms here that our harmonics have increased, and so our THDs have gotten worse here. We're at about 0.4%. SNRs still don't look too bad above 90 dB, but the THD plus noise is hovering around minus 48 dB. So with the volume control set to maximum, you could get 4 volts out with about 1.9 volts going in. I've adjusted the volume control so that we have the SX-828 working as a regular receiver with the preamp and power amp sections tied together. The volume control is adjusted to give 25 dB. We've got about 5 watts into 8 ohm loads. Our THD is better than 0.02%, we'll say. SNR is above 76 dB. So overall, it's looking fairly decent. Right now, we have the SX-828 putting out about 55 watts or so into 8 ohm loads. You can see our THD is better than 0.1%. It's meeting specification. SNR is above 82 dB, and the THD plus noise is minus 60 to minus 67. So in case you're wondering what the harmonics look like, here they are. You can see that there's not a lot of difference between the left harmonics, between the second and third. However, between the third right harmonic and the third left harmonic, the odd harmonic is a bit higher. So that's kind of what you would expect. I'm going to go ahead and increase the signal input till we get to the max power before that THD gets all wacko. So we'll go up in half dB increments, and right there at about 61 watts or so, you can see we're at 1%. It's getting pretty ugly. So, maybe you'd hit 60 watts, but you really wouldn't want to expect much more than that from this amplifier. This interesting plot is the frequency response from 20 Hz to 20 kHz of the SX-828 using the auxiliary input, and the volume controls were set to give 25 dB of gain, and we're putting out about 5 watts into 8 ohm loads. The reason I say it's interesting is because the preamplifier had a very nice frequency response, and the power amp section had a very nice frequency response. For some reason, when they're connected together, there must be something going on, because now the frequency response at about maybe 8 kilohertz and above for the left channel and about 10 kilohertz for the right channel. It's gone up quite a bit here, maybe up to 3.2 dB for the left channel, and it's down about 1.6 dB for the right channel. It should be plus or minus a dB over this range. This plot shows the SX-828's output impedance, and if you use the value at 1 kHz, that translates to a damping factor of about 30. The specification was 40, so overall I would say it's fairly close. This plot shows the Pioneer's THD versus frequency for several different output power levels, and that's into 8 ohms. The minus 29.3 dBV input would be about 300 milliwatts output, and the minus 8.3 dBV input would be about 40 watts into 8 ohms. The specification for THD is it should be not more than 0.5%, and we're basically better than 0.1%, except right here below, I don't know, 22 hertz. It has a lot of distortion at 22, 23 hertz for whatever reason, but once we get above that, it looks really pretty good regardless of the power level. Here is the SX-828's amplifier's multitone response. This is just the amplifier section, and it's showing between about 11 to 14 bits of distortion-free range. There was no specification for this back then. It's just kind of for your information. This plot shows the SX-828's crosstalk, and this is with the active channel putting out 5 watts into 8 ohms. There is no specification for the crosstalk. It spans from 20 hertz to 20 kilohertz, of course. You can see the worst crosstalk here at the high end of the bands, probably about 37 dB, and then at 1 kilohertz we're about 57, 58 dB. Right now we're looking at the system noise of the SX-828 with it connected to 8 ohm loads. I'm using the auxiliary input, which are terminated into shorts. And you're just kind of seeing the system noise, which is predominantly from the power supply at 60 hertz, 120, 180 hertz, and so on. The actual noise doesn't look too bad, but this will be heard if you just terminate the inputs and hook it up to most speakers, or at least somewhat efficient speakers. You'll definitely hear a little bit of hum. Probably won't be real loud, but we'll find out how it sounds later on. This plot shows the effect of the filters that the SX-828 boasts, and I'm just showing the right channel. The thick blue line here is the reference point, or everything is set flat for that. Now our first filter is the loudness filter, and it's supposed to be down about 3 dB at 60 hertz, and it's pretty close to that. This guy in green here, the high filter, it's supposed to be down about 3 dB at 6 kilohertz, and it's fairly close to that. Our loudness switch right here, this guy in purple, well, it's a variable loudness effect. So when your volume control is more in the attenuation setting, it will boost your highs and lows more. Right now I've got the volume control set for 0 dB gain. It's about mid-range as far as its position, and you can see it's boosting the highs, maybe a dB here, and at the lows maybe 2 dB or so. But if I were to have the volume control a bit less, I'm sure these would go up a bit. Right now we're looking at our standard 1 kilohertz THD SNR plot with a 5 millivolt signal going to the Phono 1 input, and that's the moving magnet phono input. The SNRs are right around, we'll say 53 dB. You can see the gain of the phono stage is about 36 dB, and I'm measuring at the tape monitor output. THDs are real low, 0.003%, and you can see our THD plus noise is minus 53 dB. We're seeing some effects of the power supply here, the 60 hertz, 120, and 180 hertz, that are kind of driving up the SNRs. And I do have the RIAA weighting applied, so it kind of levels out this curve here. And you can see that overall it doesn't look real bad. Most likely thumb here could be heard. Here is the frequency response of the SX-828's Phono 1 input, and that's being measured at the tape monitor 1 output. It doesn't look too bad till we get to, I don't know, that's probably about 13, 14 kilohertz, and then we're above a dB. But at the very high end of the band, at worst case, we're off by 2 dB. However, once we get away from that, we're within plus or minus 6/7 tenths of a dB. So overall, the frequency response doesn't look real bad. These little glitches here are due to the power supply. Right now we're looking at the difference in phase between the signal going into the SX-828's auxiliary input and the output signal. Just the right channel is being used, is at the 8 ohm load that's connected to the SX-828. You're just seeing the difference in phase, which isn't very much at all at 1 kilohertz. Now I will point out that I did have to invert one of the inputs. I believe the output signal I inverted by 180 degrees so that the phase difference thing would work. So automatically it inverts the phase between the input going into the SX-828 and what comes out of it as being when it's used as an integrated amplifier. At 10 kilohertz, that phase difference is greater. I'm guessing that's probably around 20 to 25 degrees, something like that, and that's once again between the input and output, with the output inverted by 180 degrees. And at 100 hertz, that phase difference is much less, probably less than 10 degrees or so between the input and the output. And when both the left and right outputs at the loads are measured, the difference in phase at 100 hertz is not very much. There's a small amount of difference, and one of them is not inverted. The output signals are the same basic phase as going in. You don't have to invert them when you're looking at both of them compared to each other. At 1 kilohertz, you can see the phase difference between the left and right channels at the output is more. It's probably 5-6 degrees, I'm guessing. And then when we go to 10 kilohertz, or 10.25 kilohertz, it's probably about 20 to 30 degrees of phase shift maybe between the left and right channels, which is the most I've seen on any amplifier or receiver that I've measured so far between the left and right outputs. And of course they have the same signal going into them, and I'm not inverting either channel. Once again, they're both on the same as far as the scope's concerned. Here is the rise time of just the right channel. Once again, our input signal's in purple. It has fairly fast rise time compared to the output, which is what, 7.5 microseconds. There is no specification for this. It's just kind of for comparison. And this kind of just shows the difference in phase with a 1 kilohertz square wave going in, and you can see between the input signal, which is the purple, and then the output. So that's kind of what I mean by they're out of phase by 180 degrees. As you saw from the test data, there's kind of mixed results for this particular Pioneer SX-828. It basically met the 54 watts into 8 ohms, both channels driven at 1 kilohertz. And at lower power levels, when I did the THD versus frequency testing, it did pretty good. It was better than the 0.5%. Now, there is a spec that at 70 watts into 8 ohms with one channel driven, it should be able to do that with less than 0.5% at 1 kilohertz. I didn't show that data, but I tried doing it, and it just really won't get much above 60 watts or so without that distortion getting a lot over 1%. Also, you saw the preamp section had a boost at the high end a lot. I believe it was the right channel was a dB, maybe 2 dB, and then when the two sections, the power amp section and the preamp section, were mated together, that was exaggerated even more. So, that was kind of the only disappointment. The phase measurement that I did between the input and output, sometimes we do see phase inversion by 180 degrees. That's perfectly fine. However, I thought there was a lot of phase difference at maybe 100 hertz and then at 10 kilohertz between the input and the output. That's more than what I normally see when I measure amplifiers. So I don't know that that's a bad thing. When both channels were measured against each other, the left channel and the right channel each going into a load, there was a bit of phase difference, more than I normally see. So that's just one of those things. This particular 828 had been worked on at some point in time. At least you can see where it looks like they had removed the wires on that tone control board. You can see where the soldering iron had melted against the wire, and you know that happens. But there were maybe 3 caps, 2 or 3 of them, that looked like they were replaced. And other than that, it, you know, fairly original unit as best I can tell. And you know, when all things were said and done, and I hooked it up to the Wilson Watt 3 Puppy 2 loudspeakers and listened to it, I thought it sounded really good. Now the nice thing was I was able to use the loudness control, switch it on like I normally do, and with lower volume levels it had a much more pleasant effect. And I apologize for not measuring that actual gain change with the volume control at a lower setting, other than at the 25 dB gain setting or so that I normally would run the volume control at. So the loudness control did not show as great of an effect with the unit set for 25 dB of gain, but when I listened to it, when it was at much lower volume control setting, the loudness control had a nicer effect. And for the most part, I thought the music sounded really, really good. I was able to cruise in the mid 80 to maybe 90 dB SPLs, which is fairly loud, and it really doesn't get warm or anything. It just kind of cranked along. The only time I thought it didn't really sound good, at least on one track, was the highs sounded just like I needed to turn down the treble control. And I was playing, you know, close to 90 dB, maybe 88 dB SPLs, and the highs were just a little bit too much, and probably because the frequency response boosts the highs at a certain spot. I'm not sure that was my imagination, because I don't know how well I hear above 10 kilohertz. I do know that I can hear 10 kilohertz, and that's about where I think those changes were with the frequency response for at least the right channel. But that was the only little problem. I thought everything else, you know, sounded very nice at a little bit lower, you know, normal listening levels. So I thought, you know, it worked really well. You know, everything seems to work nicely, other than I didn't check the tuners. So full confession, I did not check to see how well the tuners work. But Pioneer usually does a pretty good job with their tuners. So, you know, that's kind of a take on it. I saw one of these on eBay. I believe it was fully conditioned, the Goldface plate one, for, you know, $1,800 or so. The non-Goldface plate ones run, you know, $500 on up. So, you know, it's a nice vintage receiver. I think it has a nice look to it. The sound, I thought, was fine. You know, it has a few quirks, but you know, all vintage gear is going to have some quirks. It's fairly easy to work on as far as that goes. Now, I did adjust the bias and the DC offset on it. They were off just a little tad, but it didn't really make any difference in the measurement. But anyway, I did do that. So that's kind of it. It's a neat looking Pioneer amplifier. Has a lot of nice features. So maybe one day one will be yours. Once again, if you liked the video, thumbs up, and I always look forward to your comments or questions. And please subscribe to the channel if you have not. And until next time, have a great day or night.